Assalamu alaikum. My name is Muhammad Aram, and today we are making this video to record a simulation of the mid and final exam of microcontrollers and embedded systems. So the problem which was given to us in this mid and final exam of lab of microcontroller and embedded systems was to design a line following robot that should have the following features. Should follow a black line using 3 IR sensors, a climate controlled air conditioning system using temperature system, sensors LM35, and motors speed should be controlled using pulse width modulation, and we have to connect two LEDs in series to the motors, and that will show the gradual increase in the speed. And then the robot should have hurdle detection system, in which it should detect an obstacle, and then the motors will restart. And finally, all of this system should be controlled using two microcontrollers and using any of the serial protocol communication. So let's go to our project. This is our main project that I have designed on PROTEUS. You can see that we had to make a line following robot using 3 IR sensors. I have connected 3 IR sensors here, and a motor driver L293D. The second statement was temperature sensor should be used LM35 for climate control that should show the readings. Here is the temperature sensor that is connected, and then the third statement was that motor speed should be controlled using pulse width modulation. That is done in our code, and we had to connect two LEDs in series. You can see here that two LEDs are connected in series to the motor that will show the output. And for the hurdle detection system, that was the fourth statement, we have connected ultrasonic sensor that will detect the obstacles, and the robot will stop eventually. And the final statement was to use two microcontrollers, one which is used for LCD displaying and other for transmitting the signal. As you can see, here it is, one is transmitter and the other is receiver. We have used UART serial protocol communication here. UART stands for Universal Asynchronous Receiver or Transmitter. So this is our project. Now we will run. Here it is running. You can see यहाँ पर दो जो मेन इश्यूज़ आ रहे थे वो ये थे कि एक तो ये पूरा सिस्टम बहुत ज़्यादा स्लो रन कर रहा है। ये मुझे समझ नहीं आ रही थी कि क्यों हो रहा। मैंने काफ़ी इस इशू को सॉल्व करने की कोशिश की, लेकिन इवेंचुअली नहीं हो सका। आई थिंक सो कि जो हमने UART प्रोटोकॉल यूज़ किया है, जिसमें दो माइक्रो कंट्रोलर यूज़ करने थे, उसकी वजह से शायद CPU पर लोड काफ़ी हो गया है, इसलिए स्लो चल रहा है। बाकी यू कैन सी दैट द मोटर्स आर रनिंग, द LEDs आर टर्न्ड ऑन। और जो दूसरा इशू जो इसमें आ रहा था वो डिस्प्ले का था। ऑल्दो के कोड में जहाँ तक मुझे लगता है कि सब कुछ ठीक था, लेकिन डिस्प्ले नहीं ठीक शो हो रहा था। आई डोंट नो क्यों। मैंने काफ़ी ट्राई किया इसको सॉल्व करने का, लेकिन नहीं हो सका। क्योंकि अब डेडलाइन बहुत करीब है इसको सबमिट करवाने की, तो इस वजह से ये सारा आपके सामने है। और क्योंकि हमने दो माइक्रो कंट्रोलर्स यूज़ करने थे, इस वजह से अभी इसी तरह सबमिट करवाना पड़ेगा इसे। बाकी यू कैन सी दैट everything is connected. Temperature sensor is here, obstacle is here, obstacle detection. It will control the distance of the obstacle. These are the microcontroller IR sensors. Now we will go towards the code. It is running. Now we can see the code. This is a transmitter, so first see the code of transmitter. Let's stop it here. ये हमारा ट्रांसमीटर का कोड है जो हमने लिखा है. First of all, we have defined 16 megahertz frequency. Then we have used the AVR library, and then there are other libraries like for interrupts, and another library for delay, and a standard library for using variables. So here we have defined the 3 IR sensors that we have used. क्योंकि हमने प्रोजेक्ट में 3 IR सेंसर्स यूज़ करने थे, तो इसलिए यहाँ पर हमने 3 डिफाइन किए हुए हैं. One is right IR sensor, the other is middle one, and the third one is left. Here we have defined the trigger and echo of the ultrasonic sensor, and then the function start. This is a UART function. Then we have made a function for sending unsigned data type and another function for sending constant data type. So these are the functions for using pulse width modulation that we had to use in our motors. And as we had two motors, so there are two timers, and we have used double duty cycle for the pulse width modulation mode. So these are the functions for left and right motors. Further on, we have made 4 more functions to turn right, go straight, and turn left. This whole code is for transmitter microcontroller that we have used in our simulation, and we have set the motor speed initially, that is 150 RPM, and it is of the double data type is for your motor speed. That is all. As we go further, this whole function is for ultrasonic sensor. This whole function from here to here, this is for ultrasonic sensor. We have used port D and used the pins of port D for echo and trigger, and then in port B we have used the pins to enable the motor drivers, and in port C we have used for this other sensor. This is the function where analog to digital conversion is enabled, and it is happening, and the timer 0 and timer 2, these are for motors. We have used an infinite while loop that will go on running as long as the robot is moving. So here it is. The next part is of temperature sensor. This whole process is going on for the temperature sensor. We have started an analog to digital conversion here in this step, and then we have used a while loop for conversion. As we move on, it is a mathematical expression for conversion of analog to digital signal, and then it will store the value after conversion. Then as it is a transmitter, so we have used send underscore string function to send the data to the receiver so that it can display on the LCD. We have introduced a delay of 80 milliseconds, and then as we move on, we can see all of these functions that are below are for the movement of the robot. The first if condition is for turning right, where pin B is the output, and the second is for turning left, and if both of them does not happen, then the robot will move straight. Then comes a function for right motor for pulse width modulation. Since we had to start the motors gradually using pulse width modulation, so here it is. We have used OCR 0A for right motor and OCR 2A for the left motor. Both of these functions are for PWM mode of the motor. This function is for resetting the timers and setting to fast PWM mode, and this timer control counter register 0B is used for starting the timer. Similarly, this is for second motor. And then comes the function of moving straight. For moving straight, both the left and right motors should be moving with same speed, so that is why we have enabled both the motors. And when the robot has to take a left turn, then the left motor will stop and the right motor will move. Similarly, for taking the right turn, the right motor will stop and the left motor will keep on moving, so that the robot turns left. As long as the robot detects an obstacle ahead, both of these motors will stop. As you can see that we have made the right motor and left motor null, and then the function is for transmission enabling using UART. In this step, the transmission is enabled, and then we have used the 8-bit data mode, and this is for UART baud rate register value, which we have set to 1 and then we have made functions for sending data to the receiver. We have used while loops so that it constantly sends the data. Similarly, we have used send string for sending constant data type, and like the previous loop, we have used a while loop here also. So here it is, the initialization function for interrupts. We have used interrupt here, so when the logic changes in this step, the interrupt is enabled, and here the external interrupt is enabled. So next comes the functions for calculation of ultrasonic sensor for detection of obstacle. So here is the function, and here is the calculation. We have sent the data, and finally here it is for starting the counters, and if the counter does not start, then the timer is set to 0 and the count is stored in the wave. So this was our transmitter code. Now we will move towards the receiver code. Here it is, the code for receiver. Since we had used two microcontrollers, that is one was transmitter and the other was receiver, so this is the code for receiver that will receive the signals from transmitter and will display them on the LCD. So here it is. First of all, we have used the VR library, then we have used 16 megahertz frequency, and then we have used the delay library, and then an LCD library for displaying the signals. So here it is, the main function. It was a small code since it was a receiver one, and it only had to receive the data and transmit to the LCD for display. So first of all, we have initialized the LCD, and then we have used the pin 0 for D as input, and the output is taken at 4B. And then we have set the baud rate, and as we move further, we have set the higher bits of UART baud rate register, and then the lower bits, and then we have enabled the reception and transmission. and then this step is for selecting database. We have used a data type for storing the data which is received, and then we have used a while loop that will go on running infinitely as long as the data is received. So another while condition for waiting till the buffer is empty, and then we had to store the value in the UDR register, and then we have used an if condition so that if the data is null, then the LCD will be cleared, and if the data is not null, some of the data is still coming, then the received data will be displayed on the LCD. And we have introduced a delay of 100 milliseconds. So this was the code for the receiver. These were the codes for both the transmitter and the receiver. So the serial protocol communication that we have used here is UART. Since we were allowed to use any of the protocol serial communication, so I used UART since it was more convenient. So as far as the issue goes of slow processing, I think that it was related to my CPU, my computer or laptop, because I tried so much to solve this issue, but I was unable to. So I am submitting like this since the deadline is very near and I do not have much time. So this was it. Thank you so much. I tried to resolve the slow processing issue, but since it was not resolving, so I decided to try the simulation using one microcontroller, and I designed one, and here it is. As you can see that it is displaying the temperature, and here are the IR sensors and obstacles. The main issue was of display in the previous simulation where we had used two microcontrollers. So I think I don't know what is the issue regarding this. So since we had to use two microcontrollers in a problem, so that was our this. So this was my final simulation model of Proteus that we had to submit. So I am going with this. Otherwise, using a single microcontroller was displaying the output very clearly, as you can see here. So I don't know what was this issue. So thank you so much for watching.